When it comes to the exam, your deployment world really revolves around two core platforms. On one side, you've got the simple, serverless world of Cloud Run, and on the other, you have the raw power and flexibility of Google Kubernetes Engine, GKE. We're going to cover both in detail. Let's kick things off with Cloud Run. This is Google's serverless platform for running containers. You just bring your code, and it handles the rest. Now, for the exam, you'll need to master more than just deploying a service. You have to know how to configure its scaling and its performance. That's key. A modern CI/CD pipeline is a core concept you are for sure going to be tested on. As you can see here, it's a multi-step process. Your code gets built into an image. Then, a release is created. After that, it moves through different stages. Maybe it automatically deploys to a dev environment, but then requires a manual thumbs up before it hits staging and finally production. This controlled, staged rollout is critical for reliability. Okay, here's a concept you absolutely have to nail down: immutability. Every single time you deploy to Cloud Run, you aren't just updating the old version. No, you're creating a brand new, unchangeable copy called a revision. And this is incredibly powerful. It means the old version is still there, perfectly intact, which lets you safely split traffic between the old and the new. This is the magic behind advanced strategies like Canary and blue/green deployments. Now, when you're configuring a Cloud Run service, you'll face this critical choice on CPU allocation. On one hand, always allocated means you pay to keep an instance warm and ready. This is perfect for apps that are sensitive to latency or do background work because it eliminates those nasty cold starts. On the other hand, only during requests lets you scale all the way down to 0. It's incredibly cost-effective for services with unpredictable traffic. On the exam, you'll have to weigh this trade-off between performance and cost. And here's a perfect real-world scenario to make that concrete. Imagine your application uses a machine learning model that takes 8 seconds just to load up. A user is not going to wait that long for a response. So what's the solution? You set the min instance count to 1. This forces one instance to always be running, which basically pre-warms your application and gets rid of that painful cold start for your users. All right, now that we've got the basics down, let's level up and look at the more advanced Cloud Run patterns. See, the exam isn't just going to ask you to deploy a simple web service. It will test your ability to build event-driven systems and manage your services with a proper API gateway. And this is where EventHeart comes in. Think of it as the central nervous system for your event-driven applications on Google Cloud. It listens for events from over 90 different sources, like a new file landing in a cloud storage bucket, and uses them to trigger your Cloud Run service. And here's a key detail for the exam. EventHeart delivers these events in the standardized Cloud Events format, which makes your code much more portable and predictable. So how do you add API management features to your service? Well, for a lightweight solution, you can use Cloud Endpoints. It deploys as a sidecar container, running right alongside your main application. This sidecar intercepts all incoming requests and can handle things like authentication, rate limiting, and logging, all without you having to change a single line of your application code. For the exam, knowing the difference between Cloud Endpoints and its bigger sibling APIG is crucial. Use endpoints for simple service-level control. But if you need a full-blown API management platform with developer portals, monetization, and deep analytics, then APIG is the correct choice. Just think of it this way. If your API is a product you're selling, you need APIG. Okay, let's switch gears to our second major platform, Google Kubernetes Engine, or GKE. We're going to focus on GKE Autopilot, which is Google's fully managed Kubernetes experience. With Autopilot, you just focus on your application workloads, and Google manages all the underlying infrastructure for you. This is a rule you cannot forget for Autopilot mode. You must specify resource requests, how much CPU and memory your application container needs. So why is this mandatory? Because Autopilot uses these requests to provision the exact right-sized infrastructure for your pods. It's also how it bills you. If you request too little, your app might crash. If you request too much, you're just wasting money. Health checks are another non-negotiable concept in Kubernetes, and it is so important to know the difference between the two types. A liveness probe asks, is the application container healthy? If it fails, Kubernetes kills and restarts the container. A readiness probe asks, is the application ready to serve traffic? If it fails, Kubernetes simply stops sending it new requests until it recovers. This is vital for managing startup sequences or temporary overload. Auto-scaling in Kubernetes happens in 2 dimensions. First, the horizontal pod autoscaler, or HPA, scales out. It adds or removes copies or replicas of your pod based on metrics like CPU usage. Second, the vertical pod autoscaler, or VPA, scales up. It actually adjusts the CPU and memory requested by each pod, helping you optimize your resource usage over time. Okay, now let's cover a few advanced GKE topics. These are the strategies that separate a basic deployment from a truly production-grade one. This is all about ensuring your deployments are safe, reliable, and cause zero downtime. Kubernetes offers several strategies for zero downtime updates. The default is a rolling update, which incrementally replaces old pods with new ones. A blue/green strategy involves deploying the new version alongside the old, then cutting over all traffic at once. And a canary deployment lets you de-risk a change by sending a small amount of live traffic to the new version first. How do you handle application configuration in GKE? For non-sensitive data like environment variables or feature flags, you use config maps. For sensitive data like passwords and API keys, you use secrets. But here's a critical tip for the exam. By default, Kubernetes secrets are only base64 encoded, not encrypted at rest. The certified best practice is to integrate GKE with Google's Secret Manager for true, robust security. All right, let's bring it all together. Many exam questions will be scenario-based, so you'll need to quickly compare these two platforms and decide which one is the right tool for the job. Think of this table as your ultimate cheat sheet. In Cloud Run, you scale by adding instances. In GKE, you scale by adding pods. Cloud Run uses a simple YAML for configuration, while GKE requires more detailed Kubernetes manifests. Cloud Run's autoscaling is simple and request-based, while GKE offers sophisticated metric-based autoscaling. The bottom line for the exam, choose Cloud Run for simple, stateless services, choose GKE for complex, multi-service applications. And that covers the core deployment concepts for Section 3. You now know how to deploy on both Cloud Run and GKE. So the final question to leave you with is this. Now that you know how to deploy using health checks, staged rollouts, and autoscaling, how will you use these tools to build applications that aren't just running, but are truly reliable? That's the mindset you need to pass this exam.